We still won't.
Okay, we're recording. All right, so we're going to look at dilations today. Dilations are where we take a shape and we're going to resize it using a scale factor. We've talked about scale factors before. We've done bigger, smaller. When you guys, earlier on in middle school, we did the mini-me project where you had to do a scale model of yourself and do a little cartoon. So this is, you have a point of dilation. And for what we're going to do with these, since they're on a graph, is our center point of dilation is going to be the origin. So it says a dilation of 5. That means we are going to multiply all coordinates by 5. So this is a situation where we're going to want to actually list out what the coordinates are. So let's start with J. So J is 1, 1. If I multiply both of those by 5, I get 5, 5. So I'm going to go over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5. And here's J prime. It's a lot further from 0 than J was. And then if I do B, B is 1, negative 1. If I multiply that by 5, I get 5, negative 5. So I go right 5, down 5, and here's B prime. And then F right here is just 0, 0. If I multiply 0 by 5, what do I get?
0.
0, 0. So that one's not going to change, and that's because it's at the origin. So we're going to keep, that's also F prime if you want to mark that out. And then we can connect these points. And essentially what we get is a much bigger version of the same triangle. The angles will be the same, but the sides have changed.
Wow.
So basically it's increased. We call this an enlargement for obvious reasons. It got bigger. So we'll write that over here. And we're also going to talk about, this is not the same thing as when we did translations, rotations, reflections. On those, we were moving the shape around, but we didn't change anything. Here, we're actually making it bigger, but the angles are still the same. So this is similar to the original one. It's the same shape, but it's different size. So when we were looking at translations, rotations, reflections, everything was congruent. This is going to be a similar triangle, okay? Because it's the same shape, but we've enlarged it by 5 times. Alrighty. So, let's go ahead and look at number 2. So this is a dilation of 2.5. So that means we're going to multiply all the coordinates by 2.5. And I didn't leave myself a lot of space over here, but we'll figure it out. So let's start with F up here at the top. Here, I'll do it down here. So F, the original coordinates are 0, 2, and we're going to multiply both of those by 2.5. So if I take 0 times 2.5, I get 0. If I take 2 times 2.5, it's 5. And so this is what F prime is going to be. So it's going to be at 0, 5. So that's going to be F prime. So basically to go from here to here, I am multiplying everything by 2.5. Okay, if I go over to R, my original coordinates are 2, 0. So I'm going to get the same numbers as this one, but backwards. So R prime would be 5, 0. So it's going to go out here, and that's going to be my R prime. Okay, E is over here, and that E is negative 1, 0. So if I take that times times 2.5, negative 1 times 2.5 would be negative 2.5, and then 2.5 times 0 is just 0. So I'm going to go left 2.5. There's E prime. And then I just have this one at the bottom, which I think says I. So I'll do that one over here. So I is 0, negative 1. So I prime is going to be 0, negative 2.5, because I'm going to take negative 1 times 2.5 to get negative 2.5. So this point goes from here down to negative 2.5. We have I prime. So if we connect all these, we will see that we have, again, enlarged the picture, and we have a similar shape. We use the word similar in math to mean it's the same shape, but we changed its size. Okay, so this is another enlargement. So I'm going to put that over here because it did get larger. And they will talk about a center of dilation for these. The center is 0, 0. And you could draw lines through to each of these points. It's not super exciting to look at that when it's on the coordinate plane, but they will say that the center is the origin a lot of times when you're doing this. Okay, so everybody got that figured out? All right, so let's look at number 3. We're going to have a dilation of 1/2. So we're going to multiply everything by 1/2. So I'm going to start with n. What are the coordinates of n?
2.
Okay, so 0, 2, good. And then I'm going to take everything times 1/2. If I take 0 times 1/2, I get 0. But if I take 2 times 1/2, basically it's half of 2 is 1. So this point, basically, we're taking 1/2 times 2, you get 1. So that's n prime. So n prime is going to be down here at 1. Huh, that's closer to the origin than, instead of getting bigger, I think it's getting smaller. So let's do e. So e is 0, 3. So what I'm going to have to do is take 1/2 times 3. Another way you could think of it is taking 3 and dividing it by 2, because basically you're dividing in half.
Yeah, it's
1.5 or 1.5, either way. So I'm going to get 0, 1.5, and this is going to be my e prime. It's kind of all squished together. And let's do v. So v is at 3, 5. So basically we're just dividing each of these in half. So 3 divided by 2 would give us what? 1.5 or 1.5. I'll use 1.5 this time. And if I take 5 and divide by 2, you're going to get 2.5. So I'm going to have 1.5, 2.5. There's my v prime. And it's okay that's inside the shape. If you want to start connecting it, you can kind of see how it's going to be the same, but smaller. And then t is over here at 3, 1. So if I take 3 divided by 2, I get 1.5 again. And then 1 divided by 2 is just 1/2, so you could call it 1/2 or 0.5. And so then we can go to 1.5, 0.5. There's t prime. And if we connect it, it should look like the same shape, but this time it's smaller. So why do you think it's smaller?
Because it's dividing it by 1/2.
Yeah, because it's half, and half is the same thing as dividing it by 2. So we call this a reduction. Enlargement and reduction are words they use on copy machines a lot. I don't know if you guys have messed with these copy machines, but if you tell it you want an enlargement on the big copy machines, then it'll go through and ask you if you want 120% or 150% or 200% and whatever. Makes it larger, and reductions makes it smaller, but all of your pictures will still look the same, just bigger or smaller. Okay? And then, oh, and so another thing that I could have talked about, if you want to still think of this as multiplication, you could change the 1/2 to 0.5. And if you had some crazy numbers, you could, in theory, use your calculator to multiply everything by 0.5. I felt like this wasn't that hard, but if you were checking things and something didn't look right, then you could check that by multiplying everything by 0.5 to figure it out. Okay, so let's look at a dilation of 3/2. So let's talk about 3/2 for a second. If I make that into a mixed number, what would that be?
It'd be 6.
So we did these by doing long division. 3 divided by 2 is 1. 1 times 2 is 2. We get a remainder of 1. So it ends up being 1.5, which makes sense because 2 halves would be a whole, and then you have another half, which makes it 1.5. So if you want to still think about this as being multiplying, and if you wanted to save time and use your calculator, we could think of it as multiplying by 0.5. Okay? So if we take all of our points, let's just start with n at the top. They've got n is 0, 2. So what we're going to do is we're going to multiply both of these by 1.5. So let me just show that works. So I'm going to take 0 times 1.5. So on n prime, that's just going to be 0. I'm going to take 2 times 1.5, and that's going to give me 3. So I can go 0, 3, and there's n prime. So it's a little bit bigger. And let's just go clockwise. Let's do r. So r, the coordinates are 3, 1. So I'm going to take 3 times 1.5. And if you do that, you end up with 4.5. And then I'm going to take 1 times 1.5, which is just going to be 1.5. So I have to go to 4.5, up to 1.5, and that would be where my r prime is. And we can connect those if you want to go ahead and start looking at it, so you can see that it has the same shape as this line. We just made it a little bit longer. It's half again as long. All right, let's go down here to D. So D's coordinates are -2, -1. We're going to multiply both of these by 1.5. So -2 times 1.5 is -3. This is going to make D prime. And then I have -1 times 1.5 would be -1.5. So -3, -1.5 is right here. That's going to be D prime. And if we connect it, you can start seeing the shape coming together. We've got a couple of sides now. And it looks the same, but just got a little bit bigger. And then if I do A on the bottom, the coordinates for A are -1, -2. So remember that I have to multiply both of those by 1.5. So my A prime is going to be -1.5, -3. So -1.5, -3 is down here. That's A prime. And we can just go around and connect all the dots and see that it's a little bigger. So since this one got bigger, it's an enlargement. So when your scale factor is bigger than 1, it's going to be an enlargement. If it's something smaller than 1, it'll be a reduction. And that's all I have.